Math 1108, Section 7.4, Solve Rational Equations. When solving equations with rational expressions, we want to find all restricted values, then find the least common denominator of the rational expressions in the equation. Multiply every rational term on both sides of the equation and simplify. Solve the resulting equation, and if a solution to the equation that you solved in part 4 or in step 4 is a restricted value, then it cannot be listed as a solution to the original equation. Okay, so we'll follow those 5 steps to solve some equations with rational expressions. This first one, 1 over y plus 2 over 3 equals 1 over 5. The variable appears in only one denominator, and so the restricted value, there's only one restricted value, y cannot be equal to 0. The least common denominator, which is the least common multiple of the denominators, is just y times 3 times 5, or 15y. And then we will multiply every term on both sides by 15y. I'm going to write 15y as 15y over 1 to remind me that it has a denominator of 1. 15y over 1 times 1 over y, and then plus 15y over 1 times 2 over 3, and that's equal to 15y over 1 times 1 over 5. The reason we want to multiply every term on both sides by the least common multiple of the denominators is so that every denominator reduces to a factor of 1. Some refer to this as clearing the denominators. In this first product, you see that y divided by y cancels, so we're just left with 15 over 1 times 1 over 1, which is just 15. In the next product, 3 goes into 3 once and into 15 5 times, so this becomes 5y over 1 times 2 over 1, which is 10y. And on the right hand side, 15y over 1 times 1 over 5, 5 goes into 5 once and into 15 3 times, so this will simplify to 3y. And we have a fairly simple equation to solve. We can subtract 10y from both sides, so that 15 equals negative 7y, and then divide both sides by negative 7, so we get the solution negative 15/7 equals y. And then we note that this number, negative 15/7, isn't restricted, so we'll assume that we did all of the work correctly, and negative 15/7 is the solution. Okay, in the next equation, we want to solve 2 over x plus 2 plus 4 over x minus 2 equals x minus 1 over x squared minus 4. Notice that x squared minus 4, when factored, is just the product of the two other denominators. So the least common denominator is just x squared minus 4, or you can leave it in factored form, x plus 2 times x minus 2. But I'll just reiterate here that the least common denominator is x plus 2 times x minus 2. The restricted values are negative 2 and positive 2. We'll keep that in mind. The next step, we multiply every term on both sides of this equation by the least common denominator. So I'll write it as x plus 2 times x minus 2 over 1, multiplied by 2 over x plus 2. Then we'll multiply the next term also by the least common denominator, x plus 2 times x minus 2 over 1 times 4 over x minus 2. And then the right-hand side, I'm going to write the least common denominator in expanded form, x squared minus 4 over 1, and then multiply that by x minus 1 over x squared minus 4. Okay, so in each of the products, we're going to get a cancellation. In this first product, the x plus 2 factors cancel, and we're just left with x minus 2 times 2. And then in the next product, the x minus 2 factors cancel, one from the numerator, one from the denominator, and we're left with the factor x plus 2 times 4. And on the right-hand side, x squared minus 4 divided by x squared minus 4 equals 1, and we're just left with x minus 1. The resulting equation is fairly simple to solve. It's just a linear equation in one variable x. So we'll do the algebra and arithmetic. Combine like terms on the left-hand side. We get 6x plus 4 equals x minus 1. And in the next step, we'll do a couple of things at once. We'll subtract x from both sides and also subtract 4 from both sides. So we get 5x equals negative 5. And then divide both sides by 5, we get x equals negative 1. Note that negative 1 is not a restricted value, so negative 1 is the solution to that original equation. You can always check if you want to replace every x in the original equation with negative 1 and do the arithmetic and verify that the resulting equation is true. Okay, in this next example, once again we have denominator x squared minus 7x plus 10, which is just the product of the other two denominators. So the least common denominator is just in factored form, it's x minus 5 times x minus 2. Or you can write it as x squared minus 7x plus 10 if you want. Then the next step, just like the previous examples, we multiply every term on both sides by the least common denominator. So I'm going to use the expanded form, x squared minus 7x plus 10 over 1, to multiply the term on the left-hand side of the equation by the least common denominator, x plus 13 over x squared minus 7x plus 10. And then multiply each of the terms on the right-hand side by the least common denominator in factored form, x minus 5 times x minus 2. So since I'm running out of space, I am going to do it the lazy way. I'm just going to multiply the least common denominator by the entire quantity that's on the right-hand side, 6 over x minus 5 minus 4 over x minus 2. And then in the next step, we'll just do the distributive property by multiplying the least common denominator over subtraction. In this first product, the x squared minus 7x plus 10 divided by x squared minus 7x plus 10 is equal to 1, provided that x is neither 5 nor 2. So the left-hand side simplifies to x plus 13. And then on the right-hand side, when we multiply x minus 5 times x minus 2 over 1 by 6 over x minus 5, the x minus 5 factors cancel. So we'll just have x minus 2 times 6. And then in the next product, we have to multiply x minus 5 times x minus 2, in effect, by negative 4 over x minus 2. The x minus 2 factors cancel. So here, make sure that you subtract the entire product, 4 times x minus 5. And now we'll just do some algebra and arithmetic. I might need a little more space, so I'll start over here on the left. X plus 13 equals 6x minus 12. Here you have to make sure you're careful. We're going to subtract 4x. Usually everyone gets that part right, but we also have to subtract 4 times negative 5, which is minus negative 20, which is equivalent to adding 20. Okay, we'll combine like terms on the right-hand side. So x plus 13 equals 2x plus 8. And in the next step, I'll do two things at once. I'll subtract x from both sides and also subtract 8 from both sides. So when I subtract 8 from both sides and subtract x from both sides, I'm going to get 5 equals x for the solution. And that is a restricted value. No, we didn't label those earlier. The restricted values are 5 and 2. But since the solution to the equation that we got after clearing the denominators is a restricted value, we have to say that the original equation has no solution. So that equation has no solution.